Hello, this is Josh Patel, and today I'm bringing you another biology lesson. Today we are doing Chapter 2, Chemistry of Life, Lesson 1, Atoms, Ions, and Molecules. Today's lesson is a little complicated, so make sure you pay attention. Our key concept for today is all living things are based on atoms and their interactions. And when they say interactions, they're talking about the atoms. So they're making a pretty big statement here saying all living things are based on atoms, which are really, really small. They're considered the building block of life. Living things consist of atoms of different elements. So an atom is the smallest basic unit of matter or life. An element is one type of atom. So let's go back once. An element is one type of atom. So one atom can be considered an element. So if you have one atom with a certain amount of protons and electrons, it's considered a certain element. So you can have an atom of silver or an atom of gold, which is an element. An isotope is an atom that has a different number of neutrons but retains all the same chemical properties. So neutrons are what stays in the is part of the nucleus. It's a subatomic particle that's clustered in the nucleus, and the nucleus is the center of the atom. So an isotope just has a different number of neutrons, but it's basically the same thing. So this lesson has a lot of chemistry to it. So if you're confused, it's okay. We don't need to know all of this, but make sure you familiarize yourself with this. So hydrogen atom is a heavy hydrogen. So it's just these two pictures are just showing a type of isotope. So oxygen atom O18 can be used to track the movement of oxygen through chemical reactions. You don't need to know that, it's just an example. An atom has a nucleus and an electron. So we're learning the parts of an atom now. So the nucleus has protons and neutrons. The nucleus is the middle of the atom. It's the center. And it includes both protons and neutrons. So let's go back one. So okay, protons, P for positive. So protons have a positive charge. And neutrons, most people think it's a negative charge, N for negative. But look closely, you'll see another word. Neutron sounds close to neutral. So if you remember, neutron has a negative charge. And you can also think of the neutral neutron lives in the nucleus. So that's another way to remember. The nucleus contains neutrons. So let's go over it one more time. Protons have a positive charge and neutrons have a neutral charge. So electrons are the other subatomic particle in an atom, and electrons are in energy levels outside the nucleus. So they surround the nucleus, they surround the protons and the neutrons. Protons and neutrons touch each other and they're like together in the nucleus, while electrons float outside of it. So this blue circle here is the nucleus, which it usually doesn't look like that. It's usually a bunch of little smaller balls, and you can see the difference between protons and neutrons, but this picture doesn't show it. And it shows 8 protons and 8 neutrons, and these are the energy levels surrounding it. And it's not a flat disk like this. It can go either direction. It's in a whole 360, so it goes everywhere. They just fly around. So these orange dots are the electrons, and electrons have a negative charge. So if you have a positive charge, you need to have a negative charge to counter it out. And there will always be the same number of protons as there are electrons. So there's 8 protons here, there are 8 electrons here. So 1, 2, 3, 4, 5, 6, 7, 8. Yep, there's 8. So they cancel each other out. So the atom itself has a charge of 0, which all atoms have. A compound is made of atoms of different elements bonded together. So water is an example, H2O, 2 hydrogen, 1 oxygen. So this is an atom, this is an atom, and that's an atom. There are three different atoms in this compound. So a compound is one or more of two different types of atoms. Carbon dioxide is also another type. This is just an example showing how they bond, which we'll learn later. Many other carbon-based compounds are in living things. So life, if you ever watch alien movies or things, they talk about carbon-based life forms because all life is based upon carbon. And these four compounds, they're called the four macromolecules, which basically these four in all life, they basically make up life. Ions form when atoms gain or lose electrons. So another vocab word we need to know, ions. An ion is an atom that has gained or lost one or more electron. So if you remember, electrons are the things that float around the nucleus and they have a negative charge. So ions actually have a different charge. They're not neutral, but they're still an atom, so it's kind of confusing. So positive ions lose an electron, which that's pretty confusing itself. So positive would be a plus sign, so it has a positive charge as a whole, but it loses an electron. So let's use an example. Let's say we have an atom that has 10 electrons and 10 protons. So it has 10 positive protons and 10 negative electrons. So that those cancel out and we have a charge of 0. But let's say we lose an electron. So we have 10 positive protons and 9 negative electrons. So we have one more proton, which would give us a charge of positive 1. So we have a positive ion there. And now let's say we have negative ions gain electrons. So let's say we have 10 positive protons, 10 negative electrons. Let's say we gain an electron. So now we have 11 electrons, 10 protons. We would have, even though we have one more of something, it's an electron with a negative charge. So we have a charge of negative 1 because we have one more negative thing in our atom. So ionic bonds form between oppositely charged ions. So there's two types of bonds we're going to learn. This is the first one, ionic. And you need to remember they are between oppositely charged ions. So a positive and a negative ion combined. So this is our example. So we have sodium, which is Na, and chlorine, which is Cl. So the ultimate goal of all bonds for atoms is to get an octet, which is the outside ring, this ring of your atom, to have 8 electrons in it. So that's the goal of all atoms. They want to get 8 electrons in their octet, which is their outer ring. So sodium, let's see, it only has 1 electron in its outside ring. So it either needs 7 more, or it needs to just lose 1, so its ring underneath it will have 8. So losing 1 is way easier, so that's usually what it does. And then chlorine has 7, 1, 2, 3, 4, 5, 6, 7, and it wants 8. So it's just going to gain 1. So sodium and chlorine would easily combine because they have good qualities. This one can just give off its 1 electron to chlorine, and chlorine will have 8, and so would sodium. So this is how they look later. So sodium just loses its whole outer ring because there's only 1 and it gave it away. So it has 8 underneath, and then chlorine's happy too because it gets all its 8. So this is called ionic bonding between oppositely charged ions. And now we're going to learn about covalent bondings. Atoms share pairs of electrons in covalent bonding. So sharing is caring, so S and C. So sharing is caring, caring, covalent bonding. A covalent bond forms when atoms share a pair of electrons. So remember, sharing is caring. It helps you remember this. Atoms can form multiple covalent bonds. Covalent bonds are the strongest type of bond, so they're way stronger than ionic. So you can see how they share these middle electrons. So we have oxygen, carbon, and oxygen, CO2. So, see carbon dioxide right there, CO2. So they both still have 8 in their octet, which that's the goal. So 1, 2, 3, 4, 5, 6, sorry. 1, 2, 3, 4, 5, 6, 7, 8. So oxygen gets 8. This oxygen is the same thing. 1, 2, 3, 4, 5, 6, 7, 8. And then so does the carbon atom in the middle. It also gets 8. 1, 2, 3, 4, 5, 6, 7, 8. So they efficiently share all their electrons to get 8 in their octet. And that's the goal. It's really strong because they're all combined together. They're like basically connected. So that's the end of Chapter 2, Chemistry of Life, Lesson 1, Atoms, Ions, and Molecules. This lesson used a lot of chemistry, and it might be really complicated the first time you see it. So make sure on this video that you replay and watch it again to remember everything better, or you could look in your book. So thanks for watching today's video, and our next video will be on Chapter 2, Chemistry of Life, Lesson 2, Properties of Water. So water has covalent bonding, which was that last one we just learned, which is really strong, which gives it all its special properties. So it's just a intro to our next video. And stay tuned and good luck in your quest in biology.